Hello students, welcome back to Effortless Chemistry. Already we have started P block elements and we have completed group 15 successfully. Now we are going to start a fresh group, that is group 16. Okay, so I will start group 16. Group 16 elements. In this one, since this group 16 it starts from oxygen, it is called as oxygen family. It is also called as what? Oxygen family here. Okay, so what are the elements of this group 16? Elements are oxygen, sulfur, selenium, tellurium and polonium. I will write with the star mark, that is a radioactive element, and another man-made element is livermorium. It is also radioactive in nature. So in this group 16, the chemistry of these four elements will be of more importance because these two are radioactive elements, so it is difficult to study their chemistry. Next thing is these group 16 elements. These group 16 elements, they are also called as chalcogens. They are also called as what? Chalcogens. Chalcogen means ore forming elements. Simply, these group 16 elements, they are available in the most of the metal ores. That's why these are called as what? Ore forming elements. For example, already in the metallurgy we know that the most reactive elements, they are available in the nature in the combined state. In the earth crust, metal is also present and oxygen is also present. Metals are highly electropositive and oxygen is what? Highly electronegative. They will readily combine together to form what here? Metal oxide. So this is what? Metal oxide is nothing but it is the ore of the metal from which you are extracting the metal here. So this ore, they will contain what? Either oxygen or the sulfur. Even sulfur is also present in the earth crust. Metal will readily combine with sulfur to form the metal sulphide. So that most of the metals, the highly reactive metals, they are available in the form of their oxide or in the form of their sulphide. So these ore, they contain what? Oxygen or the sulfur. That's why these group 16 elements are also called as what? Chalcogens, nothing but the ore forming elements. We know that these metals are obtained by the reduction of the metal oxide. Reduction is nothing but just to remove the oxygen. Removal of oxygen is what? Reduction here. So just by the reduction of this metal oxide, you will get metal plus oxygen. Here also you can remove the sulfur, you will get metal and the sulfur. Okay, again we know that this metal, whenever it is exposed to the environment, again it will combine with oxygen, again it will form what? Metal oxide only. For example, iron, it will form a brown scale on its surface. It will form what? Brown scale on its surface, that is nothing but Fe2O3. The same thing will continue. Again you have to extract that from the oxide. Okay, so this is the what the meaning of chalcogens. Simply chalcogen means ore forming element, because these group 16 elements, most of them are present in what? Ores here. Okay, the next thing we will go for occurrence. Occurrence. First one we will write oxygen. So keep in mind, oxygen is most abundant element in the earth crust here. It is most abundant element in earth crust. So here earth crust contains 46.6% of the oxygen by the mass. In earth crust, 46.6% of oxygen is present by the mass. Okay. Next, in the atmosphere, the dry air contains the dry air, it contains 21% of oxygen by volume. This is what the occurrence of the oxygen. Next I will write occurrence of sulfur. Now I will write sulfur. This sulfur is the least abundant in the earth crust because earth crust contain only 0.03 to 0.1% of sulfur in it. So it is least abundant element in earth crust. Okay, because earth crust contains only 0.03 to 0.1% of sulfur in it. But this sulfur in the most of the ores, it occurs in the combined state as the metal sulphides or as the metal sulfates here. In combined state, sulfur occurs as metal sulfates and metal sulphides. So here whatever I am writing now, you have to answer one question from this one. One question is there in the NCERT. List out all the important sources of the sulfur. You have to concentrate on these things now. As the sulfates, I will write first sulfates. This is first one is I will write gypsum. It is available as gypsum. It's also available as Epsom salt and in the form of barite. Gypsum is calcium sulfate dihydrate, CaSO4 2H2O. Epsom is MgSO4 7H2O. Barite is simply it is barium sulfate. In the form of sulfate, it is available as a gypsum, Epsom as well as barite here. Now I will write sulphides of this sulfur. As a sulphides, it is available as galena, zinc blende and in the form of copper pyrites. Sulphides in the form of galena, zinc blende or in the form of copper pyrites. Galena is nothing but PbS, lead sulphide. Zinc blende is nothing but zinc sulphide and copper pyrites is CuFeS2. Okay, this is what copper pyrites. Next thing, organic materials like protein, egg, next garlic, onion, mustard, hair and wool also contain sulfur. These are the main sources of the sulfur. Organic materials like protein, egg, garlic, onion and mustard, hair and wool, all these contain what? Sulfur here. The next elements are selenium and tellurium. Selenium and tellurium, these occur as metal selenides and metal tellurides, in sulphide ores. This is what the occurrence of oxygen, sulfur, selenium and tellurium. The last one I will write polonium. Polonium is what? Radioactive element. Polonium is radioactive element, occurs as decay product of thorium and uranium. Okay, it is a radioactive element. Already I have written with a star mark, so that its chemistry is not of much importance, because it is difficult to study its chemistry. So this is what the occurrence of oxygen, sulfur, selenium, tellurium and then polonium it is. Okay, out of these elements, oxygen is the most abundant element in the earth crust here. Next thing we will write, what is the general electronic configuration for the group 16 elements? That is, already we have discussed in the beginning. We will write general electronic configuration, GEC, that will be nothing but NS2 NP4. Okay, it is what? General electronic configuration for group 16, because they are having 6 valence electrons here, just 2 electron less than the octet. To complete octet, just they are having what? 2 electrons short here. Okay, we will write electronic configuration of remaining elements: oxygen, sulfur, selenium, tellurium, polonium, and the last one is livermorium. These two are what? Radioactive elements. How to write the atomic number? Already we have discussed it is. So atomic number is what? 8. You add 8, you will get 16. You add 18, you will get 34. Again you add 18, you will get, this is 34 plus 18, you will get 52. 52 you will get. Again you add 32, you will get 84. You add 32, you will get 116 it is. Okay, 8, 16, 34, 52, 84 and 16 it is. Okay, I will write the electronic configuration. First one, it is helium 2s2 2p4, 8 electrons are done here. Okay, atomic number is 8. This is 16. First you will write noble gas configuration, that is neon. Up to neon is 10 is done here. So 3s2 3p4. Next selenium, this is argon. Here 4s2 4p4. Before 4s orbitals, 3d orbitals are filled here. Same thing you have to write argon. After that one you have to write krypton. So after 3d you have to write 4d10. This is a 5s2 and this is 5p4. And for polonium you write xenon. Before 5d orbitals, 5d10 orbitals, 4f orbitals are filled here. Next, this is a 6s2 6p4 will write. Livermorium, this is a radon. You write 5f orbitals completely filled, then 6d10, and this is 7s2 7p4. This is what the electronic configuration of group 16 members here. Okay, 8, 16, 34, 52. Okay, this is a 52. Then you will get 84, and it is last one is livermorium, that is 116. So all of these, they are having 6 electrons in their valence shell like this. Okay, this is what electronic configuration. Next thing, you will write atomic properties. Atomic and physical properties. atomic and physical properties. First one we will discuss atomic size. So this one already we know that down the group what happens here, atomic size increases. What is the reason for that one? In each element there is addition of new shell takes place, because of that screening effect increases, effective nuclear charge decreases, atomic size increases. Already we are well versed with these concepts, because if I go for sulfur, that is first I will write oxygen, sulfur, selenium, tellurium and polonium. This belongs to n is equal to 2, n is equal to 3, 4, 5, 6, like this. In each element there is addition of the new shell. Because of the addition of new shell, what happens? Atomic size increases. As the number of electrons in the inner shell increases, screening effect also increases. Already we have discussed in the group 15, that is. So here what happens? Down the group, that is due to addition of new shell in each element, screening effect increases, effective nuclear charge, I have written ENC, effective nuclear charge decreases, hence atomic and ionic radius or ionic size increases down the group in case of what? Group 16. So from here to here atomic size is increasing because of increase in the n values. So this is what atomic size variation. So the next point is we will discuss ionization energy, that is second point. Ionization energy. Okay, we will discuss ionization energy of group 16 elements here. Already we know that from left to right atomic size is decreasing like this. Atomic size is decreasing up to group 17 here. So if it is a group 17, immediately before this one group 16 will come, and this is what? Group 15. So these group 16 elements are having what? Smaller size. Because of their smaller size, effective nuclear charge increases. Small size atom, effective nuclear charge is more, because electrons are continuously added to the second shell in case of what? Group 16, that is second period. Okay, then what happens here? We know that from left to right atomic size decreases in this manner up to group 17. I will take this is a group 17, smallest size. Okay, and this is what? Group 16. Again very next to the group 17, 16 will come. So these group 16 elements, they are having what? Smaller size. Because of their small size, effective nuclear charge is very very high. As effective nuclear charge increases, size of the atom what happens here? Decreases. Because of their smaller size, are they having highest ionization energy? Yes, they are having high ionization energy because of their small size and high effective nuclear charge. What happens here? They are having high ionization energy here. So I will write one point. Because of their small size and high ENC, high effective nuclear charge, they have high ionization energy. They have what? High ionization energy here. So within the group what happens here? Down the group what happens? Atomic size is increasing. As atomic size increases down the group, what happens here? Ionization energy decreases. Down the group ionization energy decreases with increase in atomic size with increase in the atomic size. Already we have compared the ionization energy of group 15 and 16 in the group 15 only. So that is ionization energy of group 15 is more than the group 16. That is the reason already we have discussed, that is nothing but due to the extra stability of half filled p orbital configuration of group 15 elements. Ionization energy of group 15 is more than what? Group 16. We will once again we will compare that one. One question is there in the NCERT. Compare the ionization energy of group 15 and group 16 elements. Compare first ionization energy. I will write IE1. First ionization energy of group 15 and group 16 here. I will write group 15 element here, so that this is group 15. I will write below, this is group 15 and this will be group 16. For group 15 element, the general electronic configuration is NS2 NP3, and for this one this is NES2 NP4. Okay, group 15 element large size, 16 element small size. So with respect to size, group 16 element must have highest ionization energy because of their small size. But here what happens, due to the extra stability of this half filled p orbital configuration, group 15 elements are having highest first ionization energy as compared to the group 16 elements here. So what happens here, removal of electron become very difficult in case of stable half filled p orbital configuration as compared to NP4 here. This is NP3, NP4. This is more stable and this is less stable. Difficult to remove the electron, easily electron can be removed here. So if I compare the first ionization energy of group 15 and 16, 15 is more than the group 16 here. And after removing another electron, after first ionization energy, one electron is lost from the both group like this. So next its configuration become as what? NES2 NP2, and now this become as what? NES2 NP3. So if I want to remove another electron, that is second ionization energy I will call it as, now the electronic configuration of group 16 is more stable as compared to 15. Now the removal of electron is difficult for NP3 configuration as compared to NP2. That's why the second ionization energy of group 16 is more than the group 15 here. So if I take nitrogen, phosphorus and arsenic, in group 16 element oxygen, sulfur and selenium. So in this one, first ionization energy, I will call it as what? First ionization energy here. First ionization energy of nitrogen is more than what? Oxygen. Phosphorus more than sulfur, arsenic more than selenium, like this you have to write. So what is the reason I have to write here? Due to extra stability of half filled p orbital configuration, first ionization energy, that is IE1 I will write. IE1 of group 15 is more than IE1 of group 16. Okay, this is the reason you have to write here. This is what the comparison of ionization energy of group 15 and 16, and within the group always we know that with increase in the atomic size, ionization energy decreases here. Okay, next point we will see, that is the third one, electronegativity. Already we have discussed electronegativity in the group 15 also. This electronegativity will be highest for the small size atoms, and these group 16 elements, because of their smaller size, they are having what? High ionization energy. First point, because of small size, group 16 elements are highly electronegative in nature. So already we know that this electronegativity is very high for the small size atoms. Left to right, what happens? Atomic size is decreasing. I'll write here like this. Okay, so group 17 elements are having smallest size in the periodic table, and in the group 17 the first element is fluorine, that is having highest electronegativity in the periodic table. Next to the fluorine, oxygen is second highest electronegative element in the periodic table. Okay, next to fluorine, and right, next to the fluorine, oxygen is highest electronegative element in periodic table. Okay, the electronegativity series we can write here. Already in the classes I have told so many times that shortcut. Fluorine is highest electronegative, fluorine, next comes oxygen, nitrogen and chlorine. These two are almost nitrogen and chlorine, they are almost having same electronegativity, but if you compare size, according to the size, nitrogen is small size and chlorine is large size. Because of that nitrogen is slightly more than the chlorine here. Okay, this is what the decreasing order of the electronegativity. Next, down the group, what happens? Down the group, automatically electronegativity decreases with increase in the atomic size. In group 16, electronegativity decreases down the group with increase in atomic size. So what happens? Oxygen is highest electronegative element in the group 16, that is oxygen, sulfur, selenium, tellurium and polonium. In this one, this is the order of what? Electronegativity in the group 16, because down the group what happens? Atomic size is increasing, means their electronegativity decreases. Okay, so this is what the electronegativity of group 16 elements.